In this video, we will learn about preparation and identification of gases, different types of gases. So the first gas that we are going to take is hydrogen, H2, its chemical formula. By the reaction of active metals, take any active metal, for example, in this case we are taking zinc, but you can take any other active metal as well. And we will mix it with dilute sulfuric acid. Okay, dilute means there is water also present in the sulfuric acid or hydrochloric acid, any one of these two acids. So any active metal, zinc plus dilute sulfuric acid, what happens actually is this sulfate group goes to the zinc, and what remains? Hydrogen. So we get hydrogen. Okay, as you can see in the image, the crystals of zinc sulfate will be formed and also hydrogen gas will be released. Okay, then also we can use a base in place of an acid. For example, in this case we can use NaOH, KOH, any of these. In this case we are using NaOH, sodium hydroxide. So zinc, any active metal with base sodium hydroxide, gives us H2 also. The byproduct will change, okay, from the first one. Now, how can we identify this gas? We have seen how we can prepare the hydrogen gas, but how can we identify it? It is colorless and odorless gas. You can't see it, so this is not the method of identification. It is neutral towards litmus, so you cannot identify it with litmus as well. But a blue splinter is extinguished in hydrogen, but hydrogen burns with a pale blue flame, producing a pop sound. As you can see here, there are different ranges of colors of flame. Hydrogen produces a blue flame, and also a pop sound will be heard when the hydrogen gas burns. Okay, going ahead, the second gas that we are going to take is oxygen. So how can we prepare oxygen, and then how can we recognize it? By heating potassium chlorate, KClO3, or potassium dichromate, potassium permanganate. All of these dichromates, permanganates, and chlorates, take any of these and heat them. When we heat them, what happens is oxygen gets separated with them. Okay, so what we get? O2. In this case also we are taking hydrogen peroxide, heat it, we will get O2. Obviously we will also get a byproduct, which in this case is H2O. And this one, by heating alkali metal nitrates, this is different from the first one. This is another method of preparation. You can also use alkali metal nitrates. So take any alkali metal nitrate, heat it, we will get oxygen, we will get byproduct as well. When oxygen leaves from this nitrate group, what remains? NO2, but oxygen will leave in the form of O2. But this is an unbalanced chemical equation. Okay, going ahead, how can we recognize oxygen? As you know, oxygen is also colorless, it is also odorless, it's present in the atmosphere, it's also neutral to litmus. It rekindles a glowing splinter when passed into colorless alkaline solution of pyrogalol. The solution turns brown. So this fourth one is the important method of identification. Okay, going ahead, water vapor, that means H2O. Water, the chemical formula of water vapor is also H2O. Steam, which we can say, by heating hydrated salts. Okay, so take any hydrated salt. What does hydrated salt mean? Salt we know, but hydrated salt means salt with water. So here CuSO4 is the salt and H2O is water. So water with salt is called as hydrated salt. So heat any hydrated salt, we will get CuSO4 plus 5 times H2O. Also we can take bicarbonate of that salt, Na2CO3 of that salt, and then heat it. What happens when we heat? The water will leave. Also, as you can see in the image, this blue color of the crystals is due to water present in it. When the water will leave, blue color will also leave. Okay, so that is the method of recognition. It is colorless and odorless. It forms clear liquid on condensing. The liquid turns white anhydrous copper sulfate blue. Okay, so first copper was without water, and then when we add water, because of the water, blue color will be formed. So this is the method of identification of the salt. The liquid turns blue cobalt chloride pink. We can also use this one. Okay, if we have the cobalt chloride. Now the fourth gas, carbon dioxide. How can we prepare it? By heating metal carbonates of hydrogen carbonates. So we have to take hydrogen carbonate in this case. Okay, with dilute HCl or any one of these two acids. So calcium carbonate plus dilute sulfuric acid, it will give us calcium sulfate plus H2O. This is the byproduct. We are not concerned with this. What we are concerned with, CO2. Now how does it give CO2? When calcium carbonate is treated with an acid, actually the CO3 compound leaves and is replaced by SO4. So SO4 will go here, and CO3 should leave, but CO3 will not leave as CO3, it will leave as CO2. So that is what happens because CO2 is stable than CO3. Same in the case of NaHCO3, sodium hydrogen carbonate. Same thing will happen. Chlorine will replace HCO3. So it will make NaCl plus H2 and CO3 will leave as CO2. Easy. Now, how can we recognize it? It is colorless and odorless gas. It turns blue litmus solution paper red. Burning wood splinter gets extinguished in carbon dioxide. Okay, so when there is enough amount of carbon dioxide, the burning wood will extinguish. So carbon dioxide is used as an extinguisher as well. When the gas is passed into lime water, it turns lime water milky due to the formation of insoluble calcium carbonate. This is the reaction for that. This we can also use as a method of identification if we have lime water. Going to the fifth gas, sulfur dioxide. How can we prepare it first? We can prepare it by the action of dilute sulfuric acid. Obviously, the best method of preparation of sulfur dioxide is by dilute sulfuric acid. Or we can use HCl as well on metal sulfides. So, here as you can see in the first case, we are taking sulfuric acid H2SO4 and metal sulfide Na2SO3. When these two will mix, what will happen? This SO3 is replaced by SO4. But this SO3 will not leave as SO3, it will leave as SO2 again because SO2 is more stable than SO3. Same thing will happen in hydrogen sulfate as well. This SO4 will replace this HSO3, and then this HSO3 will not leave as HSO3, it will leave as water and SO2 here. Okay. Another method is simply by burning sulfurs. Just burn the sulfur. Sulfur plus O2 gives SO2. Simple. Another method by boiling copper turnings with concentrated sulfuric acid. So if we have copper with concentrated sulfuric acid, we have to boil it. What will we get? CuSO4 plus twice H2O, and in that case we'll get SO2. Now, how can we recognize and identify sulfur dioxide gas? It is colorless gas with a suffocating smell of burning sulfur. This is important. Why? Because no gas in the previous cases had this character, a smell. It turns blue litmus solution or moist blue litmus paper red. As you can see in the image, first the litmus paper was blue, then it turns to reddish color. It turns orange colored acidified solution of potassium dichromate green. So if we have potassium dichromate, we know its color is orange. What will happen when it is treated with SO2 in an acidic medium? It will turn it to green. Okay, it decolorizes pink colored potassium permanganate solution. So if we have potassium permanganate solution, we treat it with SO2, what will happen? The color will fade away, and the reaction behind that process is this one. Potassium permanganate, we have to expose it with SO2, the color will fade because these compounds are colorless. Okay, I hope it's all clear to you.